All right, I got a good one for the first years. So in your first year of the apprenticeship, first you learn how to do math in series circuits, then you learn how to do math in parallel circuits. It usually goes hand in hand with Kirchhoff's voltage and Kirchhoff's current law. At least it does at both the apprenticeships I teach at. Once you get both of those topics down though, you then go on to combination series parallel circuits, and that's where a lot of apprentices get tripped up. So this here's part one of probably 2 or 3 videos on combination series parallel circuits. So I drew up the scenario right here. We've got 4 loads, 2 of them are in parallel, and this set of parallel is in series with 2 other loads. Usually the first thing people learn is how to calculate total resistance in a combination circuit, and it trips a lot of people up. When you have a situation like this where you have 2 loads in parallel that are in series with other loads, what you need to do is solve the parallel first, and at that point it becomes series math. It's going to look something like this. So in this case, resistance total is going to equal the resistance of load 1 plus the combined resistance of loads 2 and 3 plus the resistance of load 4. So first we need to figure out the parallel resistance of loads 2 and 3. Since it's 2 loads, we can use the product over sum formula. So it's going to be 30 times 35 divided by 30 plus 35, which equals 1,050 divided by 65, which equals about 16.1538 ohms. At this point, we can just add this resistance to 20 and 25 ohms, which is going to give us about 61.1538 ohms. That's going to be a resistance total for this circuit. Now, if we want to figure out the total current on this circuit, we're going to use the formula IT equals ET over RT, so voltage total divided by resistance total. That equals 120 divided by 16.1538, and that's going to equal about 1.962 amps. Okay guys, so just a quick little interjection right here. I just finished editing the video, and I realized I accidentally flip-flopped these 2 digits. It's not 16, it's 61. Thankfully, that did not throw off my math anywhere, but I just wanted to throw that out there. I do apologize. One thing that's worth noting, this 1.962 amps is going to carry across this load and this load, but since these 2 loads are in parallel, it's actually going to be split proportionately to the resistance of each load. We'll have to talk about that in a later video. And if we want to work out the Kirchhoff's voltage law, it's going to be ET equals E1 plus E2 and 3 plus E4. We're going to use volts equals amps times resistance. So that's going to look like this. E1, so voltage across load 1, is 1.92 amps times 20 ohms equals 39.24 volts. The voltage across loads 2 and 3 as a parallel set is going to be 1.962 amps times 16.1538 ohms of parallel resistance equals about 31.694 volts. And then the voltage across load 4 is going to be 1.962 amps times 25 ohms equals 49.05 volts. You can also figure out the power dropped across each point along the circuit, but I'm trying to keep this short and sweet, so we'll have to save that conversation for a later date. Anyways, hopefully this makes a little bit more sense. If you guys have any more questions, you can always DM me or drop it down in the comments below.